Okay, so now we're going to kind of jump into a new type of graph that maybe we haven't really looked at. So let's look at what a velocity graph is first. So acceleration in position versus time means that the position is getting larger in greater amounts over time. Okay? In a velocity versus time, acceleration means the velocity graph is simply changing. So if velocity is speeding up or slowing down, we're just going to see a straight line change in our graph. Okay? So the bigger the change, the steeper the graph, the bigger the acceleration, the bigger the net force. So here we go. Here we got some graphs. But I want to point out this to you. This is why we harp on titles. This should be titled velocity versus time. So if you see velocity versus time, is the velocity changing when you see a line like that? You see a line like this, is the velocity increasing or decreasing or staying the same? Is the numbers getting bigger along the y-axis? It's getting bigger, right? So the velocity is increasing, decreasing, or staying the same? It's increasing. If the velocity is increasing, it's accelerating. Which direction is the force? In the direction of motion. Okay? Velocity going up equals speeding up equals accelerating. Velocity going down. So you see how the graph is going down? Because we read from left to right on the graph, so the velocity is getting smaller, so it's slowing down, it's accelerating. It's a negative acceleration, which means it's against motion. Okay? And then we have a flat velocity. If velocity doesn't change, it's constant speed. No net force, no acceleration, because it's staying the same. So be careful, because your displacement versus time graphs will look different. Okay? Displacement versus time accelerating. See the curved line? Okay? That's curved. If I see a straight line on a delta D versus T graph, see a straight line, that means constant speed. But on a velocity versus time, that means the velocity is increasing, so it's accelerating. So be really careful about that. Okay, so net force, no net force. So, net force, no net force. Pause the video if you need to write some of this down. But moving along. Okay, so let's look at this graph. First thing we should do is, what's the title? We cut off the title, but this one should be titled velocity versus time. Okay, so we're looking at velocity. So let's look at this. From 0 to 3 seconds. So see right here where it says 0, and then we have 3 seconds. Is this speeding up, slowing down, or remaining constant velocity? It's remaining constant. What's the value of that constant? It's 0, so 0 meters per second is what we would read that as. See the 0? 0 meters per second. Is it changing? No. So no net force, no acceleration. I said that backwards. No acceleration, which means there's got to be no net force. There might be forces, but they're canceling out, they're balanced out with each other, okay? All right, let's look at 3 seconds to 5 seconds. We've got a very sharp, steep, straight line, okay? So that's a velocity graph. So velocity starts at 0, but where does it end? At 8 meters per second. Did the speed get faster? Yes. It increased all the way from 0 to 8 meters per second. It's increasing. That means it's speeding up, which is acceleration, which means there's a net force. What about from 5 to 8 seconds? It's a flat line. Not speeding up or slowing down, so no acceleration, no net force. And then the last one, we go from 8 meters per second all the way down to 0 meters per second. We're slowing down in this case So it's a negative acceleration, which means it's against motion. So let me walk this for you, and then I'll pop up what should be on your slide. So if I say ready, get set, go, 1,000, 2, 1,000, 3, 1,000, I increase my speed, and then I stay constant speed, okay? It's hard to do when you've got very little room, okay? So I increase my speed because I'm moving now, but then I get to 5 seconds, and now I'm just moving at a constant speed. I'm not speeding up, I'm not slowing down, and then I slow down until I stop, okay? So I'm gonna not move, I'm gonna increase my speed, I'm gonna get faster. When I get to a certain spot, I'm gonna maintain that speed, and then I'm going to slow down and stop. Okay, so section 1, here we go. We already talked about this. You can fill in the blanks. And there you go. So pause it, get that into your notes, please.